Mr. Rupke here with another video. Today we're going to be talking about counting principles, permutations, and combinations. Now let's get to an example. We have 5 students, Amber, Brian, Charles, Diane, and Emily. My first question is, how many ways can those 5 students line up to go to lunch? Well, we can start thinking about it, and we could make a list. For instance, they could line up in this order exactly: Amber, Brian, Charles, Diane, Emily. Or maybe, and I'll abbreviate, maybe it's Amber, Charles, Emily, Brian, Diane. Or maybe it's Brian and Diane, Emily, Charles, and Amber. Maybe Emily's in front, and it's Brian and Amber and Diane and Charles. And I could keep listing all of the ways until I think I have them all. But we can tell right away this is going to be a mess. And since it's going to be a mess, we should probably try to figure out a mathematical way to find the total number of ways these 5 students can line up at the door. To do that, let's picture the problem. Well, there's 5 students and they need to get in a line. First, second, third, fourth, fifth. How many choices, if they're just sitting in their seats, how many possibilities are there for who will be first? There are 5 students, so there's 5 possibilities. 5 of them can be first. Now, once one person is in first, in the front of the line, how many people are left that could be second in line? 4, exactly. Once the first and the second person have lined up, how many people are left for possible people who could be the third person? 3. First 3 are lined up. How many people are left that could be the fourth person in line? 2. And obviously just one student is left. If I multiply these numbers together, 5 times 4 times 3 times 2 times 1, I find there are 120 ways for 5 students to line up for lunch. There's a math sign that you wouldn't expect to be a math sign that we can shorten this. Anytime we take a number and we multiply all the way down to 1, we can use the exclamation point and call that a factorial. So we would read this as 5 factorial. Anytime you see an exclamation point, you just know that you're multiplying from this number all the way down to 1. So if we did 8 factorial, that would mean 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. The larger these numbers get, the more time this will take. Luckily, your calculators have a shortcut. If you go to Math, and you hit the Math button, move over to Probability, and go down, I think it's option 4, you will see this exclamation point. So for instance, if I gave you 11 factorial, you wouldn't have to do 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 on your calculator. You could just do 11, hit the Math button, go to Probability, go down to the exclamation point, and find your answer. So this is the counting principle. Anytime we want to know how many ways a certain number of people can get in a line, we use factorial to find that answer. Staying with our same 5 students, we're going to do a different type of problem. This time I'm giving them a spelling test. And I want to award a first, second, and third place prize. And my question is, how many different ways can these 5 students finish first, second, and third on their spelling test? Well, we could look at our grid, and then from our grid, we can figure out how many ways they finish first, second, and third. So let's look at the grid. Here's our list of 120 ways that our 5 students can line up for lunch. But now we need to know about finishing first, second, and third. So starting in the top left, I can see that Amber, Brian,
Charles can finish first, second, and third in that order. Amber could be first, Brian could be second, and Charles could be third. Now, looking right beneath that, it's the same order for first, second, and third, so that does not count. Then we have Amber wins first, Brian in second, and Diane in third. So this would count as another possibility. Beneath that is the same thing, so that does not count. Then we have Amber, Brian, and Emily, first, second, and third. Beneath that is the same thing, so it doesn't count. And we can continue down the list. Each time we notice Amber, Charlie, Brian cancels out with Amber, Charlie, Brian. Notice that these two are different orders. In the top there, Brian is second, Charlie is third. And in the bottom one that I have circled, Charlie is second, Brian is third. So these are different orders, and order obviously matters if they're getting first, second, and third place. Now I've gone ahead and made a new chart for you. These are the unique ways that they can finish first, second, and third. And if we count up all the yellow rows there, we see that there are 60 ways that these students can finish first, second, and third.
Okay, so if we had the grid, we can find out that there are 60 different ways that they can finish first, second, and third. But we realize we're not always going to have a grid. We're not going to want to count. There's way too many ways to make a mistake there. So how can I find this 60 mathematically? And here's how we're going to do it. Something called permutations. And with a permutation, order matters. And this is important. Order matters. So anytime we're finishing first, second, or third, anytime that we're having an election for a president and a vice president, it matters, and it is a permutation. So let's figure out how we can calculate these 60 permutations. How we would write this is there are 5 students that we have in the class. We're going to do a permutation, and we're awarding 3 prizes, first, second, and third. And that's how we would set it up. 5 permutations with 3 prizes, or 3 places that we care about. So that's how it's written as a problem. This is how it's calculated. You take your total number, 5, and we're going to use the factorial that we just saw and put that in the numerator of our fraction. For the denominator, we're going to subtract these 2 numbers. Subtract, 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 subtract. 5 minus 3 is 2 factorial. We can write it out if we want to. 5 factorial is 5, 4, 3, 2, 1. 2 factorial is 2 times 1. Again, factorial means multiply from that number all the way down to 1. Looking at this fraction, we should see that my 2 and 1 cancel with my 2 and 1. And that makes this problem a little easier. It makes it 5 times 4 times 3. And what is that answer? 60. What we found by looking at the grid. Only this way we found it mathematically. We don't need that big chart in order to count the ways. We can calculate the permutations. Order matters. First, second, and third place. 5 permutations, 3. 5 factorial, subtract your numbers to get your denominator, and then calculate. Again, if you have your calculator and you want to use the factorial function, then you can just do 5 factorial divided by 2 factorial and get our 60. Same 5 students. This time I need to choose 3 of them for hall duty. I wonder if this question is the same as first, second, and third place. Actually, it's not. It's different. Because why? If I chose Amber, Brian, and Charles, and I said, Amber, Brian, and Charles, you're on hall duty, is it any different than if I said Charles, Brian, and Amber? No, it's still the same 3 students, and they're still on hall duty. It doesn't matter what order I call their names out. Maybe I say Brian, Charles, and Amber, you're on hall duty. It's the same 3 students. So now we have to eliminate from our chart all those doubles and only find the times that Amber, Brian, Charles in any order are listed.
Previous example, first, second, and third mattered. Obviously, if Amber was first, Brian was second, and Charlie was third, that would be completely different than Charlie getting first place, Brian getting second, and Amber getting third. But in this example, where I'm just selecting them for hall duty, these are the exact same thing. It's the same 3 students going to hall duty. So I can cross out this order because we already have it circled. Are there any others that I can cross out for Amber, Brian, and Charlie? I can cross out this order of Amber, Brian, and Charlie. I can cross out this order of Amber, Brian, and Charlie, and I can cross out this order of Amber, Brian, and Charlie. What about Amber, Brian, and Diane? Are there any other orders that I can cross out because they're essentially the same thing if all I'm doing is picking them for hall duty? Well, sure, I can cross out Brian, Amber, and Diane. I can cross out Brian, Diane, and Amber. I can cross out Diane, Amber, and Brian. I can cross out Diane, Brian, and Amber. And again, you would keep doing this throughout the chart. I've made a new one for you. Now we see there are only 10 ways that I can choose 3 students for hall duty once I get rid of the doubles.
So looking at our chart, we were able to see that there are only 10 ways that I can choose 3 students if the order doesn't matter. Whether I say Amber, Brian, Charles, Charles, Brian, Amber, Brian, Amber, Charles, Brian, Charles, Amber, it doesn't matter because the 3 students are still going to hall duty. How can we calculate this? Well, first of all, we need to find a term. And this would be a combination. And there's no specific order. Order does not matter with combinations. So whether it's hall duty or if you're being voted on just to be on this like student council committee, or if a coach is picking the starting lineup, it doesn't matter. These are combinations, and this is how we're going to find it. It's going to start off looking very similar to what we did. We're doing combinations, not permutations, so it's a C. We still have 5 total students, and I need 3 of them for hall duty. The fraction sets up exactly the same at the beginning. Total students 5 factorial on the top, subtract them to get 2 factorial on the bottom. But with combinations, there's one extra step. We subtracted our numbers to get 2 factorial, but now I need this second number also in the denominator to get 3 factorial. And that's the new step with combinations. Not only do we have the total factorial on the top and the subtract factorial on the bottom, but now we have the second number factorial on the bottom. If we wanted to write this out, we would have 5, 4, 3, 2, 1. And and on the bottom we would have 2, 1, and 3, 2, 1. Now we see a lot of stuff cancels. 3, 2, 1 cancels on the top and the bottom, and we could even reduce the 2 and the 4 into a 1 and a 2. And now we see easily 5 times 2 is 10, divided by 1 is 10. And that's what we saw on the grid. So, counting principles, if we want to put all 5 of them in a line, 5 factorial. If there's 8 of them, 8 factorial. If we're choosing them for something like president, vice president, secretary, or first, second, third place, order matters. Permutations. If order doesn't matter, if I need 3 of them for hall duty, if I need 2 of them to go to detention, combinations. Order doesn't matter. And these are the ways we figure those out.